Do remember from 2 unit, okay, the quadratic equation, just looking here. Sorry, as I was saying, back in 2 unit, if we look at a quadratic equation of the form ax squared plus bx plus c equals 0, we know it's got 2 roots because it's a quadratic, and if those roots are alpha and beta, then we set it up such as this. Ax squared plus bx plus c equals a times x minus alpha, x minus beta. The reason we've got the a here is why? Because it may not be a monic quadratic. You could have 2x squared or 3x squared or whatever. Okay, so that equation you could pull out, let's say this was 2x minus 4, you could say pull out the 2 and have 2 bracket x minus 2 or something. Or even if it was 2x minus 3, you could have the 2 out, x minus 3 on 2. Okay, but if it was not a monic, you do have to write it in this form to see what the roots are. Okay, now, if we just take that, see how there's a bracket x minus alpha, x minus beta. If we now divide everything through by a, we get ax squared on a is x squared, bx on a is b on ax, c on a is c on a, and we divide this by a, we lose the a from the front. Okay? Now, if we expand this right-hand side, don't we get x squared minus beta x minus alpha x plus alpha beta? And because I had 2 terms in x, I had minus beta x minus alpha x, I can say that I've got x squared, x is a common, the x terms are common, and you can factorize out the x and you'll get minus alpha plus beta x. Do you want me to do it here or not? I can do it here. X squared minus beta x minus alpha x plus alpha beta is x squared, I'm just going to go minus x bracket alpha plus beta. Plus alpha beta. And what we've done here, you know, because the coefficient, so you're right with that, minus x alpha plus beta. So the coefficient of the x is negative bracket alpha plus beta. If the reason that that is written in front of the x is because it's the coefficient of the x. Now, you know how we know that sum of roots, alpha plus beta, you know, up here, if the roots are alpha and beta, we know that sum of roots is minus b on a, so this becomes x squared minus alpha plus beta is minus b on a, and product of roots, alpha times beta, we know is c on a. What we notice is that we've got is that we get that. Now, and if I multiply through by a, don't I have the original equation? But the main thing I want you to do is to stop here and see that what we've really got is x squared minus sum of roots plus product of roots. So see here, can you put a little note, if you're not going to write this, I want a little note here saying that this is x squared minus sum of roots times x plus product of roots. Can you see that that's of that format? So I've basically got the same thing here. This is x squared minus, oh geez. So I've got, yeah, so here. So therefore I've got x squared minus sum of roots times x plus product of roots. I don't think you can see it properly. Plus product of roots. So I want that written next to that this is x squared minus sum of roots times x plus product of roots. So x squared minus sum of roots times x plus product of roots. Got that idea? Now, we're going to do the same thing for a cubic. In the cubic equation, if we've got roots alpha, beta, gamma, then our general cubic equation is ax cubed plus bx squared plus cx plus d. Remember, we put the a out the front times the x minus alpha, x minus beta, x minus gamma equals 0. Reason, because it may not be a monic. All right. Dividing everything by a as we just did up there, we get x cubed, we get this on a, that should be an a, girls, that's a mistake. Or students, that's an a there. D on a equals x minus alpha, x minus beta, x minus gamma. Again, they're expanding the right-hand side. So if you expand the right-hand side, and I'm not going to do it all, you would get x cubed minus you'd get alpha x squared, beta x squared, gamma x squared. So these terms are all x squared, so you take out the common factor x squared and you'll have minus bracket alpha plus beta plus gamma. Because the terms you would have had would have been minus alpha, you would have had minus alpha x squared minus beta x squared in that expansion, minus gamma x squared. You would have had all of those terms in there. And also you would have these terms in x, alpha beta x, beta gamma x, gamma alpha x. They would have been terms. I'm not going to do that whole expansion, okay? But what do we notice here? That we've got x cubed minus sum of roots times x squared plus this here is product of roots times x minus, right, sorry, not product. Sum of roots one at a time, sorry, x cubed minus sum of roots. If it's sum of roots one at a time, they just say sum of roots, okay? This is sum of roots two at a time or sum of, yeah, double product of roots. I say sum of roots two at a time times x minus triple product of roots or just product of roots. Are we okay with that? So it's of the format x cubed minus sum of roots times x squared plus sum of roots two at a time times x minus product of roots. So it always goes with the highest power, then minus plus minus. See how it did it with this as well? X squared minus, because it's the minus minus b on a. That's why you've got the minus there, because the minus minus b on a gives you the plus b on a here. Anyway, look, the thing is, when we get some, if I give you an equation, or if I give you a polynomial, I don't tell you what it is, but I tell you what alpha, beta and gamma are, you can actually write the polynomial by just doing sum of roots two at a time, product of roots. Okay? So this is just going back over the rules. And then notice we've got minus b on a, c on a. Here, one at a time, minus b on a, two at a time, c on a, three at a time, minus d on a. But this three at a time happens to be the product. Remember we did this in extension 1? And for the quartic, exactly the same thing, okay? Sum of roots one at a time, minus b on a. Sum of roots two at a time is c on a. Sum of roots three at a time, or sum of triple product of roots, whatever you want to call it, is minus d on a. Sum product of roots, or four at a time, is e on a. And it's always, you always start with minus b on a. And then look at this equation, it's x4 minus sum of roots, x cubed, plus sum of roots two at a time, x squared, minus sum of roots three at a time, x plus product of roots. All right, so it's always that, then the minus, then the plus, then the minus, then the plus. All right, the reason is because it's minus minus b on a, which gives you the plus b on a up here. All right, now, all right, using those, we're just going to do some questions. Remember these, if you're just asked for alpha plus beta squared, that's the same as doing alpha plus beta all squared minus 2 alpha beta. If you want to do, now this one, alpha cubed plus beta cubed, that's just another result that you can learn off by heart. And now that we've done the binomial theorem, let's just have a look at that. What's the right-hand side of that? See, that's not the factorization of that. That's different. What's alpha plus beta cubed? Now that everyone, I think, has done the binomial theorem. Have you done it? Do you know how to expand alpha plus beta cubed anyway? What do you get? Alpha cubed plus 3 alpha squared beta plus 3 alpha beta squared plus beta cubed. By heart anyway. So 1, 3, 3, one of the coefficients of Pascal's triangle, the highest power of alpha, drop a power every time, and then you introduce a power of beta every time. Minus 3 alpha squared beta minus 3 alpha beta squared, and I'm off screen. And does that cancel? Yep, and then you get alpha cubed plus beta cubed. Look, I don't, do you know that result? I don't know that result. It's just useful, but you could derive it if you, I don't know. I haven't really used it. This is the other really useful one. Now, you can sort of think of it like this. You know how alpha squared plus beta squared is alpha plus beta squared minus 2 alpha beta? Just think here, it's the single squared minus 2 times the product of those two. This is the same. Alpha squared plus beta squared plus gamma squared, yes, it's the singles with a squared, minus, obviously you have to do the 3 combinations, minus 2 lots of alpha beta, minus 2 lots of alpha gamma, minus 2 lots of beta gamma. We can actually do that expansion and prove it, but I just think it's a really good result for you to know. Do you want to do it over here? How do you get it? I'll show you. One's if I ask you to expand this, how do you do it? You can actually, look, there's an easy way of doing it. You can just write it out twice and just multiply everything by each other. But the other way of doing it is like this, which I want to show you. So yes, you can put alpha plus beta plus gamma times alpha plus beta plus gamma, multiply everything by the first, then the second, then the third one. But this is another way of doing it. You group this together, and if you do it as a perfect square, what would I get? Don't I get alpha plus beta squared plus 2 lots of, if that is a plus b squared, you've seen this before, 2 alpha plus beta gamma plus gamma squared. That's the other way of doing it. So you get alpha squared plus 2 alpha beta plus beta squared plus 2 alpha gamma plus 2 beta gamma plus gamma squared. And then you can just put your alpha squared plus beta squared plus gamma squared together plus 2 lots of alpha beta plus alpha gamma plus beta gamma. And then if we want this, you're just taking that over to the other side. You okay with that? Now, I think it's much easier to learn the result, and if you base it on this, it's the square of the singles minus double the products. If you remember this perfect square, the top one, then it's easy to remember the other one. All right, now we're going to do a couple of questions here. All right. If alpha plus beta plus gamma is equal to 3, alpha squared plus beta squared plus gamma squared is 1, and 1 on alpha plus 1 on beta plus 1 on gamma is 2, find all of this, hence write down the equation of the polynomial with roots alpha, beta and gamma. Now a bit of a tricky one. One sec. This one?
But then you want to know what the products are.
Yeah, because we've got to work out the products, don't we? Okay. All right. Yep, all right, let's go. Yep, and because this, yeah, but then we're going to need to know the products anyway. Yep, all right. Okay, so we know that we've got 1 equation, 2 equations, 3 equations. If we look at the second one and use that result up there. Okay? Yep, all good. All right, see that result up there? Look, this is what we've got. We've got alpha plus beta plus gamma, looking at this second result. We've got alpha squared plus beta squared plus gamma squared. And we can therefore, if we if we write this equation out, substitute these results in, we'll be able to work out sum of roots 2 at a time. Do you see that? We know that. We know this. We've got values for those. And we will thus work out sum of roots 2 at a time. So that will find alpha beta plus beta gamma plus gamma alpha. Okay? So we'll start with that. So we'll start with our result. Alpha squared plus beta squared plus gamma squared is alpha plus beta plus gamma squared minus 2 lots of alpha beta plus alpha gamma plus beta gamma. Substituting in those results from the question, we know that 1 is equal to 3 squared minus 2 lots of alpha beta plus alpha gamma plus beta gamma. So just rearranging this, taking this over to the left and that to the right, you would get alpha beta plus alpha gamma plus beta gamma is 4. Okay, that's our first result. Now, using this result here, 1 on alpha plus 1 on beta plus 1 on gamma is 2. We can either go, or, I don't know if we'd go common denominator, or... Yeah, we can. Yeah, yes, because then, yep, let's do that. Okay, we'll go common denominator. 1 on alpha plus 1 on beta plus 1 on gamma is, let's go common denominator, so it'll be alpha beta gamma plus, the same thing, isn't it? Alpha beta gamma plus alpha beta gamma. No. That one, this one, and that one. First one's missing the beta gamma, second one's missing the alpha gamma, third one's missing the alpha beta. All over alpha beta gamma. Okay, so now we've got substitutions for this and that. So we can then work out what alpha beta gamma are. So what have we got? That this is 2 and that is 4, isn't it? Over alpha beta gamma. Therefore, alpha beta gamma is 2. Okay. Then it says, hence write down the polynomial equation with roots alpha beta gamma. So that, or px, whatever you want to call it. So therefore the polynomial is x cubed minus, what are sum of roots one at a time? Minus 3x squared. That's right. Plus sum of roots 2 at a time. You know how you can write it? You can go like this if you want. So you know that the polynomial, if you forget it, you can go, well, it's going to be ax cubed plus bx squared plus cx plus d is 0, which is going to be x cubed plus b on ax squared plus c on ax plus d on a equals 0. But you know that, so therefore it's x cubed plus, but minus b on a happens to be, minus b on a is the 3. Okay, so it'll be minus 3. Okay, if minus b on a is 3, then b on a is minus 3. Plus c on a is 2 at a time, which is 4x. And then minus d on a is 3, is the triple one, which is 2, but it goes minus 2, equals 0. And if you want, you can then write it as x cubed minus b on a. If you're forgetting to do that, you can even, if you want actually, you can then write that that's really that plus c on a x. Do you see what I'm doing? Minus negative d on a. Do you get the idea? So that you'll remember that it's plus minus plus minus. And it just happens, the reason it's like that is because the sum of roots one at a time happens to be positive. So that's really what it is, because it's minus and that happens to be negative 3. See, what you might want to do up the top actually is go that minus b on a is 3, c on a is 4, and minus d on a is 2. That's what I'd be writing. From that result, this, so that you don't get the sign incorrect. You get it? All right, otherwise, if you get your plus minuses here not correct, you don't want to. 2, page 16, 2 of the roots are reciprocals while the remaining roots are opposites. Let the roots be alpha, what else? 1 on alpha, beta, and minus beta. Okay, let's start with sum of roots, product of roots, etc. They want C and D. Let's just see. Remember, we've got A, B, C, D, E this time. Okay, so we've got A, B, C, D, E because it's a quartic. Okay, so sum of roots. Actually, what we want to do are the ones, we're just going to, if we do sum of roots, that's going to be good because the B and the beta and the minus beta cancel, and you'll get alpha plus 1 on alpha is minus 5 on 2. So sum of roots one at a time, alpha plus 1 on alpha plus beta minus beta equals minus b on a. So it's alpha plus 1 on alpha. I'm going to need some more room. I'll move over. So we've got alpha plus 1 on alpha minus b on a is 5 on 2. What are we going to do now? Just multiplying through by 2 alpha to solve this. Or you can write it as, oh, you know what? Oh, no, we need 2 solutions. Multiplying through by 2 alpha, what do we get? 2 alpha squared plus, so multiply through by 2 alpha. 2 alpha squared plus 2, isn't it, equals 5 alpha? Yeah. So therefore 2 alpha squared minus 5 alpha plus 2 is 0. Factorising. I'm just putting minuses at the moment. I think we need minuses. And we're going to have a 2 and a 1. It must be there. Is that right? Minus 4 minus 1. Yep, so therefore alpha is a half or 2. Now, product of roots. Alpha times 1 on alpha times beta times negative beta is E on A. Alpha times 1 on alpha is 1, so we've got minus beta squared. E is negative 18 up there. So it's negative 18 on 2. So therefore beta squared is 9, and so therefore beta is plus or minus 3. Now, let's just see where we go from here. So therefore, the roots, so therefore your roots are, what are they? A half, 2, positive 3, and negative 3. They're your plus and minus beta. Okay, now, we have to work out what C and D are. So isn't C going to be, that's A, B, C, D, E. Isn't this sum of roots 1 at a time, 2 at a time, 3 at a time? The C on A will be 2 at a time. So if we just work out the sum of roots 2 at a time using this combination here. So sum of roots 2 at a time. Now the way you can write it is just like sum alpha beta. That means sum of roots 2 at a time. Okay? You've got to do all your combinations. What's a half times 2? Plus, what's a half times 3? 3 on 2. Plus a half times minus 3 is minus 3 on 2. See what I'm doing? Make sure you get the 6 combinations. So I've done half times 2, a half times 3, a half times negative 3. Then I want to do 2 times 3, 2 times negative 3, plus 6, minus 6. So I've done, you just do the first one with each of them, the second one with each of them, and then the last 2, minus 9. So what are my sum of roots? So well, that and that cancel, and that cancel, it's negative 8. But doesn't that equal C on A? So therefore, negative 8 equals C on A, which is C on 2. In other words, negative 8 is equal to, I just need room, meaning that negative 8 is C on 2, therefore C is negative 16. Negative 16. Be careful. Okay, and we'll do the same thing now with working out D. So sum of roots 3 at a time, alpha, beta, gamma. So we're multiplying a half times 2 times 3. Are we okay? So this, when you do these, you miss out the last one, then the second last one, then the second one, and then the first one. So miss out the last one. A half times 2 times 3 is 3. Missing out the second last one, a half times 2 times negative 3 is negative 3. Missing out the second one, I've got negative 9 on 2. And missing out the first one, I've got negative 18. You okay? Which is, anything cancel? 3 minus 3. Isn't that minus 4.5 minus 18? 36 and 9. Minus 45. Minus 45 on 2. I'll just go in common denominator of 2 because, yeah, it is because that's 36 on 2. Minus 9 minus 36 is minus 45. So therefore minus 45 on 2 equals negative D on A. So minus 45 on 2 is negative D on 2. Therefore D is 45. So therefore, oh, we've worked out C and D. Done. Find the 4 roots and evaluate C and D, which we've just done. Okay. Ooh. If alpha, beta and gamma are the roots of this equation, and S1, that happens to be sum of roots 1 at a time, is alpha plus beta plus gamma, S sub 2 is not sum of roots 2 at a time. It's alpha squared plus beta squared plus gamma squared. And S3 is alpha cubed plus beta cubed plus gamma cubed. You have to prove those three results. First you have to, well, the first one's really easy to prove. You have to prove that P equals S1 isn't just S1 sum of roots 1 at a time. So start with A. Sum of roots 1 at a time, or just sum of roots, isn't it minus B on A? It's alpha plus beta plus gamma, which is minus B on A, which happens to be minus negative P on 1, which is P. That's the first one. Easy. B. You have to show that Q, isn't Q sum of roots 2 at a time? You can do your 2 at a times, or you can start with this right-hand result and show that it equals that. Okay, there's no reason why you can't. So let's start with the right-hand side. I did do it starting with the left-hand side with sum of roots 2 at a time, alpha beta plus beta gamma plus gamma alpha, and then I did the combination of that, you know, the link between that and that. It's not actually a bad one to practice. Can we do it both ways for the second one, just for practice? So, or you're going to start with the right hand. Let's just do it sum of roots 2 at a time. 2 at a time. Let's just do it the long way first, then we'll do it the reverse way, all right? Just in case you ever need to do it. It would be alpha times beta plus alpha times gamma plus beta times gamma. Now, we know that alpha, we remember the result now, don't we? Alpha squared plus beta squared plus gamma squared, isn't it? Do you remember the result? Don't look back at it. It's just like alpha squared plus beta squared is just alpha plus beta squared minus 2 alpha beta. This is just 3 of them, alpha plus beta plus gamma minus 2 lots of the 3 roots, 3 combinations of the roots. Well, I've got alpha 3 times. There. Anyway, you know what to do. Alpha beta plus alpha gamma plus beta gamma. Okay, now we know sum of roots 2 at a time equals, that's minus B on A. This is C on A, which is Q on 1, which is Q. Okay, so alpha squared plus beta squared plus gamma squared, isn't that S2? Equals alpha plus beta plus gamma. Alpha plus beta plus gamma is S1 squared minus 2 lots of alpha beta plus beta gamma. Yeah, plus that's Q. Is that right? Yeah, that's right. So therefore, Q, we're just making Q the subject. 2Q equals S1 squared minus S2. Make sure you're putting the subs and the supers, the subscripts and the superscripts correctly. Therefore, Q is just a half of those. That one's not hard to do it that way. That was actually okay. All right. Now, I don't want to be playing around with alpha cubed plus beta cubed plus gamma cubed, because right-hand side is 1/6 S sub 1 cubed minus 3 S sub 1 S sub 2 plus 2 S sub 3. And we can just substitute everything in and expand, and it is going to be a bit messy. S1, what's that? Oh yeah, alpha plus beta plus gamma cubed. Oh yeah, we're still going to have lots of fun. Minus 3 lots of S1. Oh, this is fun. And S2, alpha beta. No, it's not. It's alpha squared. Alpha squared plus beta squared plus gamma squared plus 2 lots of S3. What's S3? Alpha cubed plus beta cubed plus gamma cubed. Don't worry, this has got enough challenge in it. Well, it's not that it's hard, it's just fiddly. You know, to expand this, oh yes, you're going to group the alpha and the beta together. Because how else do you do it? So you're going to, you know how I showed you this before? Alpha plus beta, put them together. and do it as a cube using the binomial theorem and Pascal's triangle to expand the alpha plus beta plus gamma cubed. Jaden, I'm going to need that room. We'll turn it sideways. Everyone got that last line over there? Yeah. All right, so it equals, am I on screen? Yes, I am. So we've got 1/6. All right, haven't we got, isn't the first one cubed? Alpha plus beta cubed, still got a cubed, plus 3 lots of alpha plus beta squared times gamma, plus 3 lots of alpha plus beta times gamma squared plus gamma cubed, minus 3 times 3 lots of alpha cubed, but it's just going to take a while, plus alpha beta squared plus alpha gamma squared. This is ridiculous. Beta alpha squared. This is just really a time-wasting activity, and I'm still not even finished. Do you know what I mean? Plus, yeah, I am. Plus, I'm just going to close that bracket because I'm still not done. Minus, because I'm still going here. Minus 3 lots of alpha squared gamma plus alpha beta squared, and it's all over the place. Plus 2 alpha cubed plus beta cubed plus 2 gamma cubed. Oh, look, it's just one more expansion. Yeah. Okay. And we'll keep going. It's a mess. 1/6, and I still have to expand alpha plus beta cubed, but that's alpha cubed plus 3 alpha squared beta plus 3. This is a time waster. Alpha beta squared plus, sorry, next time I won't put anything like this, plus 3 lots of that. Isn't that alpha squared plus 2 alpha beta plus beta squared? So it'll be 3 alpha squared gamma plus 6 alpha beta gamma plus, isn't it 3 beta squared gamma plus 3 alpha gamma squared plus 3 beta gamma squared plus gamma cubed minus, anyway girls, guess what, it all ends up, you can play with it at home, you keep going, 3 alpha cubed minus 3 alpha beta squared, sorry Jaden, minus 3 beta, this is just a waste of time, I'm sorry, 3 beta cubed plus 3 beta gamma squared minus 3 alpha squared gamma minus 3 gamma beta squared minus 3 gamma cubed, and I've still got all the rest of that. But apparently, sorry, plus 2 alpha cubed plus 2 beta cubed, don't worry about it, I don't think you'd ever be asked this. You end up with 1/6, everything cancels except for 6 alpha beta gamma.
Even if I ask for this, I will not solve it.
Yeah, I don't even know what that says.
Y cubed.
Yeah. Where's the other alpha cubed? Can you see it? Alpha cubed.
I see 2 alpha cubed on the bottom.
2? Yeah. But that's a plus. 2, 3, yeah, and then the minus 3. See, they do end up cancelling. Okay, and there's the beta cubed and the plus beta cubed and the minus 3 beta cubed is there. They all end up cancelling. Wouldn't worry too much, and you get that, which is alpha beta gamma, which is, what's alpha beta gamma? It's up there somewhere. 3 at a time, minus r on 1. So therefore, minus r. A minus b minus, yeah, minus b plus c minus d. Sorry, minus d. So that equals minus d on a, which is minus r on 1, which is r. Are we okay? Sorry about that one, guys. Bit of a waster. I think I'll pull that one out next year.
So y,
Yeah, so far.